Hi everyone. What I have here in front of me is a pretty simple little device. Uh, it's just kind of an example of how we use a lead screw. Um, a lead screw uses what they call an Acme thread. As you can tell, if you can see the profile of that a little bit, it's a little more robust than what we know as like our standard imperial thread, we'll say. That's far more pointed. The Acme thread is blunted, and the angle of this thread is actually 29 degrees versus like 60 degrees of a standard thread that we're all pretty familiar with. So that provides a much higher load capacity potential. Um, These are very efficient for moving one thing from one end to the other along that thread, and they're pretty easy to work with. Um, Once you take into consideration two things, that the screw needs to be supported on both ends. So I have this end here, and then we have we'll say the motorized end, or in this case the handle end, that rotates the screw, and the screw is attached to what we call the nut. Now it's not the standard like everybody says get a nut, or it'd be a hex, but this here is the Acme thread nut that I actually fabricated to join to my carriage, so that when the screw rotates and it's locked in place, it's not able to travel, it just is rotational motion. The screw actually travels along that plane right there. By using the threads that are inside of the nut that I fabricated. Now, one thing that's really important when you do fabricate a lead screw, it can't be overly constrained. Now, in this case, obviously these rails on this track, we'll say, they can't be too tight, so they have to have what they call a running fit that allows them to slide freely along that rail. The other thing I want to point out when you're using a lead screw and you're making a nut, even though it's not shaped like what we call a common nut, is that if you look right here where the nut goes through our carriage plate, it's radial. It's been turned down from this diameter right here, and it's actually the same thing on the other side of the carriage. I can't show you because of the base plate that it's on, but trust me. So those 2 points, this point right here and the corresponding point on the other side of the carriage down below, are the only points that are making contact with the carriage. So that's actually driving the carriage up and down that screw length right there. Now, if that's overly constrained, it's going to bind. And by leaving that slightly loose, that not only can it rotate within that hole like this, but it also is not constrained in this orientation from this side to under this plate right here. There is a little bit of play, so that not only can the nut float this way, but it also can float rotationally. And what that does, it takes any run out in the screw out of play. And what I mean by run out is when I'm rotating this screw, if this isn't perfectly straight, it would actually rotate like this, right? So it would be spinning, but from end to end, maybe it would be running out. Now in this case, this thread's pretty straight, looks pretty good, but if there are even slight run out in that screw, it would cause binding if this nut piece right here didn't have the ability to float. When I say float, it's not just running around out in space. I mean, it is constrained, obviously, but it does have the ability to move in both of those planes. So that's something important to think of when you're doing a drive system like this using a lead screw. Now that's just driving the carriage. There's another example of that I have that is right here, the infamous scissor lift, right? We're all familiar with that. And as I rotate the lead screw, my nut, which is this section right here, again, I'm not overly constrained, otherwise it wouldn't move in my slot right here. but I have radial motion in the screw, and I also have the ability for it to find that runout that may be in the in the screw. So as I rotate this, you'll see how that works. The nut slides up and down that Acme thread. Little sidebar on an Acme thread. It's kind of cool. This type of design has been in place for, hundreds of years, and the Acme thread that's at, like I said earlier in the video, at 29-degree angle, replaced the square thread that the two sides of the threads were actually parallel to each other. And that was great until it started to wear out, which happened quite quickly because of the amount of friction that a square thread would give. So back in like the 1860s, somebody came up with putting a small angle on that thread of 29 degrees, and that changed everything. Now Acme threads are used if you close a vise on a bench. It uses an Acme thread. If you use a jack to lift a car, the precision. So that's a little touch on lead screws. Hopefully that helps.